Have you ever wondered how structures like buildings and bridges were made? Well, a lot has to do with welding. I've been welding for a few years now, and I've worked in fabrication shops where I've welded and grinded metal. Reasons for you to listen are because you might find it interesting and might, want to try out welding one day. It's a very interesting subject. I like it a lot. So, here we go. Preview is history, types, and uses. History of arc welding. Arc welding is welding through an electrical current, and the first uses of it, or first instance of it, was in 1856 with the resistance welding, which isn't super useful today. It's not our main way of welding, but it still was invented and really helped, bring about more modern stuff. And in 1881, welding by carbon electrode was invented, which is not exactly like welding today, but it's getting closer and closer as the years progress. 1919, the coated metal arc welding, which is very important because that's almost like SMAW, which is a type of welding we got onto. Welding in the Industrial Revolution. Welding in the Industrial Revolution, well, I believe that the Industrial Revolution had more of an impact on welding, the advancement of welding, than welding had on the Industrial Revolution, because not that many things back then were welded, but during the Industrial Revolution there's a lot of inventions that helped advance welding, like the resistance spot welding and carbon arc welding that I mentioned before. Welding during wartime. Welding during wartime was even a bigger advancement in the welding. During wartime, GMAW, gas metal arc welding, was invented, which is one of our main processes, and also GTAW, gas tungsten arc welding, which is also one of our main processes that we use today, was invented to help build aircrafts, weapons, and things like that. Also during World War II, or the wars, we started using welding to build bridges and skyscrapers and huge ships, and I thought that was really amazing. Types of welding processes. First one we have is SMAW. I would say this is the most widely used, and the first one that you would learn if you're going to welding school. Stick welding uses an electrical current, and what it is there's a picture here. It's hard to see because the computer and the camera don't really work well together, but what it is, you got the welder, which creates a current, and you got a ground clamp, and you got a stick holder clamp, and you put the ground clamp onto a piece of metal, and you got the stick holder clamp that has a rod, the cold electrode rod, and when you touch them together, it creates an arc, but once you separate it, it shorts the arc and creates enough heat to melt metal. And so that when that happens, it burns, so you're melting the electrode metal and the base metal, and you're using the electrode metal to fill in the weld as you go along, and the flux around the electrode rod shields the metal when it's in the liquid state. Its main uses are for outdoor structural welding or pipe welding, because it doesn't need added gases like MIG or TIG. To practice stick welding, I make 4 test plates, weld them all in all positions, and then I grind and bend test them. So what a test plate is, this is the end result of a test plate. This is a passing test plate. You can't really see, but what this is flat at one point, and it's longer. And what you do, you weld up, you fill it up, and then you cut it, and you bend where your welds are. If there's any, I'm not sure if you can see, there's like a little V in there. That's where my welds would be. And you bend at that point, and if there's any like cracks or anything, then it's a fail. But this one passed, there's no cracks or anything. You'll be able to see them. Or it can even snap in half sometimes. GMAW, the one that I talked about before that was made during the World War, or it's also called MIG, so I'm going to refer to it as MIG now. MIG uses an electrical arc as well. So it's kind of like stick welding, but instead of having a rod holding it, you have a gun that constantly has wire feeding through it. But this wire doesn't always have flux in it, which covers the metal with a gas. So you have to actually use your own gas, which can be argon, helium, a mixture of things, Main uses are indoor fabrication because it's quicker and easier than stick, you know, because it's a constant wire feeding. It's pretty easy. I like it. I like all types of welding, honestly. The way I practice this is by making a bunch of joints and just, you know, filling them up. T-joints, stuff like that. GTAW, TIG. So TIG is actually the hardest, I would say. I like it. It's fun. It's the hardest to learn, and it creates the most quality welds. So, tungsten. So for the electrode on this one, the tungsten is the electrode, but it's not consumable like MIG or stick. The tungsten just creates the arc and heats up a weld pool. And to fill a metal, you have to use a wire by your other hand to dip in the rod as you go along. I'm sorry you can't see the picture. This would explain it perfectly, but my camera's not well. And it creates really high quality welds. Also uses gas like MIG. And it makes to practice I make a bunch of different joints and then weld them up together. I got an example right here. This is stainless steel. I like welding with stainless steel. It's a lot of fun on TIG. It comes in all different colors. See how it's nice and uniform? This is called a T-joint because it looks like a T. There we go. And that's stainless steel TIG. Uses for each of these. Structural. Support beams, ornamental structures, and bridges. So structural would mean like the I-beams in a building or anything that holds up big structures. So you use welding in like buildings to you know, create joints, help hold up the building. Ornamental structures like staircases, railings, stuff like that, and bridges. Bridges is very important because, you know, I feel like that's the hardest structure to make. I feel like they're the coolest. I like this picture right here. It's pretty amazing all the engineering that goes into bridges and all the welding that goes into it. Pipe welding. So there's all kinds of pipe welding. There's pipe lining, which would be you know, out in the middle of nowhere where there's a bunch of pipes. You know, out west they have a lot of them. They don't have any in New York, but what the job would be, you go out there with your truck and you weld a bunch of pipes together, and that's it. It's a really cool job. Steam fitting, which would be you work in a building like in New York City or something, and you would weld a bunch of high pressure pipes. Well, high pressure would be going through these pipes, and you had to have really good welds for steam to go through because it's very hot and high pressure. And then underwater welding, which is very cool, and it's dangerous stuff, but it's cool. Fabrication, which is what I did. You could build a bunch of different things for fabrication. I build parts for bridges. I build concrete support beams, and build parts for machines. And you weld parts for other companies. So that's the fabrication end of it, which is a lot of it. My quote is, I'm not sure who wrote this quote because it didn't really have like an author. So, you are a welder if you have sunburn in the winter. Yeah, I get sunburn a lot when I weld. Sometimes if I'm not covered up all the way, and it's pretty bad. Thank you for watching.